Hello there and welcome to Lower 6th Further Maths A-Level Pure Core 1 Past Paper, June 2012, and here we've got a complex number question, question 7 from FP1, June 2012. And here we're asked to calculate arg of z, giving your answer in radians mode. So that's why I've got the calculator up. I'm ready in complex numbers mode to answer or check a few of these questions here. So it's arg of z, it's 2 marks, so I'm going to have to show some working for this. I can check on the calculator though. So let's first just draw a little diagram as to where this complex number is. So it's right by 2 and down by root 3. So root 3 is not quite as much as 2. So we're about here. And what we have to do here is find this angle here to find the argument. So it's going to be 2 along here, root 3 up here. So to work out this angle theta here, we need a tan angle, and it's opposite over adjacent, so root 3 over 2. So get your calculator out, and we need tan minus 1 of root 3 over 2. And we need that to be in radians mode, so just double check your calculators in radians mode, and we get 0.71. The argument of z is not 0.71. Remember, any complex numbers that are on the bottom of the argand diagram are negative, so the arg of z is minus 0.71. Let me just show you how you can check that on your calculator. So, first thing you do is hit the menu button and select option number 2. Then you click the options button and hit 1 to get the argument. You'll then get arg with your bracket. You then type in your complex number. You have to use the eng button down here to select I. You can see the purple I that's there. That's the one you're looking for. Close the bracket and then press equals, and that is your argument. So I've answered this question to 2 decimal places, so that looks about right. Okay, great. Moving on to question B, express in algebra z plus z squared. Now I can also check this on the calculator as well in the complex number mode, but it is 3 marks, so I'm going to need to do and show some working. So 2 minus root 3i. I'll first work out z squared, so 2 minus root 3i. Remember, anytime you square a complex number, it's not as easy as just squaring the real bit, squaring the imaginary bit and adding the two together. It's one of these ones where you have to expand a double brackets. So we get 4 minus 2 root 3i and another 2 root 3i, so that would be 4 root 3i. And then it's going to be positive 3i squared. Now just remember that I squared is minus 1 here, so that's a minus 3. So 4 take away 3 is 1, it'll be minus 4 root 3i. So let's add that on then to 2 minus root 3i. So we're going to get 1 plus 2 is 3 and minus 5 root 3i. Let's just check that on the calculator. So the way that I would do this on your calculator is to first of all type out your complex number and just press the equals button. And then if you want z plus z squared, using your answer button, create that summation. So answer plus answer squared, and the answer that it's using was your complex number you've just plugged in. And then we get our answer just to check it, 3 minus 5 root 3i. Perfect. The next one we're looking to do here is z plus 7 over z. So let's move that onto a new page, and I'll be ready to get this going on the calculator as well. So it's going to be 2 minus root 3i plus 7, we'll simplify that in a bit, and 2 minus root 3i minus 1. Okay, so let's just simplify this. So we 9 minus root 3i over 1 minus root 3i. So we're going to have to do a bit of rationalising the denominator here to get rid of the i's from the denominator. So times the top and the bottom by the complex conjugate. That's the method you always use to get rid of the i's from the top and bottom of fractions. So let's expand these brackets. So it's going to be 9 times 1 is 9. 9 root 3i minus 1 root 3i, so that would be just plus 8 root 3i. And it's going to be minus 3i squared. Simplify that in a bit. And then the bottom part here is going to be 1 minus 3i squared. We're going to get a plus root 3i and a minus root 3i, which will cancel. So let's simplify all of this. So I squared is minus 1, so that'll make it a plus 3. That will make it here a 12 plus 8 root 3i. And on the denominator, it's going to be 1 plus 3, so that'll make it a 4. Great, we can cancel some of this down here. 12 cancel down with a 4 will make a 3. And the 8 will cancel down with a 4 here to make it 2. So it'll be 3 plus 2 root 3i. Let's just double check that on the calculator. Yeah, that's right. So what I did there is exactly the same as last time. Plugged in my 2 minus root 3i on the calculator. Used the answer button from then on. So answer button plus 7 on the top of the fraction. Answer minus 1 on the bottom of the fraction. Press the enter button and I got my final answer there. Right. The next part of this question is going to involve a little bit of algebra, so I can't use my calculator. What a bummer. So, given that w equals lambda minus 3i, where lambda is a real constant, and the argument of 4 minus 5i plus 3w equals minus pi by 2, find the value of lambda. Right, okay. I'm just thinking about this argument of minus pi by 2. So a minus is going to bring it onto the bottom, and pi by 2 is 90 degrees. So it's going to be a number that is here. So it's going to be a number that's like minus 5i or minus 10i or minus something I. So it's not going to have any real parts to it. I'm going to use that later. So let's just work out what this 4 minus 5i plus 3w. Now w is lambda minus 3i. And this will simplify to, let's expand the brackets first, plus 3 lambda minus 9i. And here I'm going to get 4 plus 3i lambda, take away 14i. So here's my complex number that I'm working with here, and I'm told the argument of it is minus pi by 2. So I've worked out it's not going to have any real parts, so I need to write it and explain that somehow. As argument equals minus pi by 2, the real part of my imaginary number is going to equal 0. So therefore, my little nice triangle, 4 plus 3 lambda 0. So therefore lambda is going to equal minus 4, take the 4 onto the other side, and then divide by 3. So lambda is minus 4 divided by 3. No pi in there. 11 marks for this whole question. That's great.